Okay, so the next part will be about factorization of cubic polynomials. Now the first one is for standard cubic expressions. That means we are going to be following a formula. And there are two examples, or there are two formulas. One is for a cubed plus b cubed, one is for a cubed minus b cubed. Now, the first bracket, right, of the factorization will always be linear. So it's always a plus b or a minus b. Then the second bracket is your quadratic one. So it will be a square something ab something b square. Now the hard part to remember is whether it's a plus sign or minus sign. So there's an easy way to remember. So let's try with a cubed plus b cubed first. If this is a plus sign, then your first sign in your factorization, like the one in the linear factor, will always follow the same sign. So if it's a cubed plus b cubed, then the first linear factor will be a plus b. Then always remember, your second sign will be the alternate of the first sign. So if the first sign was plus, your second sign will be minus. And then your last sign will always be a plus. Now for a cubed minus b cubed, as I said just now, your first bracket will always follow the sign. So if the first one is minus, then this one will also be minus. Then your second sign, it will be the alternate of the first sign. So if first sign is minus, second sign will be plus. And then your last sign is always a plus sign. So now let's try a few examples, which is basically just plugging your values into the formula. So x cubed minus 64. Now you must find your a and your b. So clearly your a is your x. Now how do you get your b? This is basically b cubed. So how you get your b? You can do a cube root of 64, which will give you 4. Now this is your b. So you can now plug a equals to x and b equals to 4 in your a cubed minus b cubed factorization formula. So your a minus b, a square plus ab plus b square. That's why you end up with x minus 4, because x is your a, b is your 4. Then x squared plus 4x plus 16. Now for the second example, 8 plus 27x cubed. So 8, once again, you can use 8 to find your a. So if 8 is your a cubed, then a will be equals to cube root of 8, which is 2. And then 27x cubed for your b. So if this equals to b cubed, then b equals to cube root of 27x cubed, which equals to 3x. So this is your b, this is your a. Then you plug it in to this equation. That's how you get 2 plus 3x bracket a square, so 2 square equals to 4. Then minus ab, so 2 times 3x gives you 6x, plus b square, so 3x whole thing square, then give you 9x square. Likewise for this example, how you get a equals to cube root of 27x square, give you 3x. How you get your b? Cube root 125y cubed equals to 5y. So this is your b, this is your a. And then plug it into the formula, you'll get 3x plus 5y, then a square, so 3x whole thing square, you get 9x square, minus ab, so 3x times 5y, 15xy, plus b square, which is your 5y whole thing square, so 25y square. Now your final example, 432x cubed minus 2y cubed. Directly cube root like 432x cubed or 2y cubed. It will come out as like many decimal places, right? Which is like not right. So what you can do first in your first step is to factorize 2 out to make your values into one that is a perfect cube. So you got y cubed and 216x cubed. So you factorize 2 out first. Okay. And then from then on, these become perfect cubes. So you can just cube root. So cube root 216x cubed equals to 6x, which is your A. Then this one, of course, if you cube root y cubed, it just gives you y, which is your B. Then now you can plug into the formula again, this formula, and then gives you, remember your 2 outside the bracket that you factorize out at the start, and then you just plug in the formula to get 6x minus y, 36x squared plus 6xy plus y squared. Okay, then the next part is just factorization of general cubic expressions that don't really fit the formula that we used just now. So let's just learn by looking at this example. We have this polynomial, right? And then we need to factorize it into 3 brackets. So usually the first step, we will kind of speed up the process for ourselves and use the calculator to find our factors first. So technically from there, we already kind of have our answer, but of course we need to show that we understand how to get there. So we need to use our factor theorem to try out one of our factors and prove that it is a factor. So once we get our values from our calculator, then we can try x equals to 2 and then plug in, substituting x equals to 2 into our polynomial shows that it equals to 0 and conclude that x minus 2 is a factor. Now how do you get x minus 2? So you have x equals to 2, right? So you work backwards, then you get x minus 2 equals to 0. Conclude that x minus 2 is a factor. And then you will end up with 5x cubed minus 26x squared plus 35x minus 6 equals to x minus 2 as your first bracket, and then you will have another quadratic bracket that you need to find. So you can either use long division as shown here, and if you need to recall how to do long division, you can look at the previous videos. Or you can use something called the inspection method that some schools will teach. So what is the inspection method? Now if we come down here, so we can express, after knowing that x minus 2 is a factor, right, we can express it into these two brackets like what I've written out previously. So your first, this is your known factor, and then this is your other two factors into one quadratic bracket. So it's called the inspection method because once again we are comparing the coefficients on the left hand side and on the right hand side. Now it is always easiest to compare firstly the term with the highest power x and the term with the lowest power of x. So we look at the highest power first. So our highest power is x cubed. On the left hand side, your x cubed coefficient is 5. And on the right hand side, you have to multiply these two terms together to get your x cubed. Which means on the left hand side, your x cubed coefficient is 5. And on the right hand side, you can equate it to a. Because when you times these two together, you will get ax cubed. So 5x cubed equals to ax cubed, so 5 equals to a. That's how you get your first unknown. Now if we compare, secondly, the lowest power, we'll compare between minus 6 on the left hand side, and then on the right hand side, you'll be comparing minus 2 and c multiplied, because that's how you get your term that is independent of x, which means there's no x attached to it. So therefore you will end up with minus 6 equals to minus 2c. Therefore, c equals to minus 6 divided by minus 2 equals to 3. So you know that your a equals to 5 and your c equals to 3. Okay, and to find b, we compare the coefficient of x squared by firstly looking on the left hand side. The left hand side is minus 26 for your coefficient of x squared. Then on the right hand side, we need to expand. So how can we get x squared? We can multiply x by bx or minus 2 and ax square. That's why you have x plus bx and then minus 2 times ax square. That's how you get your x square coefficient. So then you end up with minus 26 equals to b minus 10, and then you get b equals to minus 16. So now we have our a, b, and c values. We can substitute back into our initial brackets. Okay, then now going back to our initial steps. No matter whether you use long division or inspection method, you will end up with these two brackets. And then you'll notice that this quadratic can be further factorized into two more brackets. So after you factorize it further, you'll get these three brackets. And if the question is to solve for your polynomial equals to 0, it means that you are solving for x. So you have to find values for x. That means you equate your polynomial to 0, and then you get x minus 2 equals to 0, 5x plus 1 equals to 0, x minus 3 equals to 0. That's how you end up with x equals to 2, x equals to 1/5, or x equals to 3. So there's a difference when the question asks you to solve or factorize a polynomial. So you must watch out for what the question is asking you and what it really wants. So to solve, it means that you need to get your values of x. So you need to get values of x, like x equals to something. But to factorize, it just means that you need to find the factors of the cubic equation. So the factors is like the ones in the brackets. So factors is like this: x minus 3, 5x minus 1, and your x minus 2. So these are your factors. So make sure you know what your answer is supposed to look like. Okay, now the next part is if the quadratic factor that you get cannot be factorized or further factorized. So let's look at this example again. We have this polynomial x cubed plus 4x squared plus x minus 2 equals to 0. So step 1, if question never represent your polynomial as fx or px, we must do this step. Let fx equals to your polynomial. And then once again, we'll speed up the process by using our calculator to find the first root of x equals to minus 1. Now if x equals to minus 1, we will know that our first factor is so we shift it over, we will know that our first factor is x plus 1. Now step 2, even though we know from our calculator that x equals to minus 1 is indeed a root, we must show this part even though if you think it's unnecessary, it's still a marking point, so we have to prove that it's a factor by using factor theorem. So try x equals to minus 1, then you sub x into your polynomial, and then you will show that it ends up equals to 0. And then hence, by factor theorem, x plus 1 is a factor. Step 3, to find your other factors, you will do your long division and make sure that your remainder equals to 0. Or we will do our inspection method. Okay, so let's try using the inspection method since the long division method is already here. So we can re-represent our polynomial as x cubed plus 4 squared plus x minus 2 equals to our known factor, which we found from our calculator, which is x plus 1, and then our unknown factors we leave as a, b, and c. So ax squared plus bx plus c. So as usual, our first factor that I already know is a linear factor, then our second bracket will be our quadratic factor. So to get the easiest ones to find will be a and c first, because once again, the highest power x and the lowest power x. So to compare coefficients for x cubed, we are looking at this and x times ax squared, because that's how you get x cubed on the right hand side. So x cubed equals to ax cubed. Now if there's no number in front, means there's an invisible 1, right? So that also means a equals to 1. So we got a. Next, let's find our c. Now to get c, we are comparing. On the left hand side is minus 2, and on the right hand side is 1 times c, because that's how you get the term independent of x. That's why c equals to minus 2. Okay, now to find b, we'll be comparing. Use x squared. On the left side, it will be 4, and then on the right side, it will be a bit more complicated. So we'll write down our 4x squared first, equals to, on the right side, it can be ax squared times 1 plus another way to get x squared will be bx times x. So it's equals to ax squared plus bx squared. So 4 will be equals to a plus b. Now we already know what a is because we found it previously over here. So we can sub in our a. So equals to 1 plus b. Now we move the 1 over. B equals to 4 minus 1 equals to 3. So now we have our a, b, and c. Then we can sub it back into our brackets. So our polynomial breakdown will be equals to x plus 1. Then we sub in a equals to 1. So x squared, b equals to 3, 3x. Then c equals to minus 2. So we get the same answer here and here. Right? Since we know from the calculator that x equals to minus 1 is the only numerical root, whereby your x is a whole number, it means that x squared plus 3x minus 2 cannot be further factorized into 2 more brackets. So for factors, we'll leave it as x plus 1 and x squared plus 3x minus 2, whereby x squared plus 3x minus 2 cannot be factorized further. However, if the question asks you to solve for x, then you cannot just stop there. You need to solve for x. Give a value for x. So you will equate this to 0, and then one of them will be x plus 1 equals to 0, which gives you x equals to minus 1. Or you will use the general formula x equals to minus b plus minus square root b squared minus 4ac over 2a to find your x. So you input all your values in here, and then that's how you get your decimals, minus 3.56 or 0.562. But you also must look out for whether the question wants the answer in surd form, because this is your non-exact answer. That's why it's in a decimal, whereby it's in 3SF. But if the question wants the answer in surd form, or your question wants the exact value of x, like solving exactly for x, then you need to leave it in surd form. So just you simplify your general formula after you plug your values in, then you'll get this one or this one.